So we are looking for horizontal asymptotes using the concept of pre-calculus just with the rational function. First look at example 1. You have x times x minus 3 over x squared plus 7x minus 4. So when you are looking for horizontal asymptote, you just say y is equals higher order term. The other free constants we drop, or other terms we drop, take the higher order. So then numerator is x squared, denominator is x squared, so y equals 1. This is your horizontal asymptote. I'm writing in short, HA. When you go to the second one, you just say y equals, take the higher order terms in the numerator and in the denominator. So you end up with 1 over x. Now you can see when x goes to plus minus infinity, that we have seen in pre-calculus, that this one goes to 0. So that means y equals 0 is my horizontal asymptote. What happens in this one? You write y equals, in the numerator you get x to the 3, in the denominator you have x squared. So this is basically x, and this blows up, goes to plus minus infinity. When x approaches plus minus infinity, y also goes to plus minus infinity. So then in this case, no horizontal asymptote. Now what happens to cosine x? We are looking for horizontal asymptote. So if you look at the graph of cosine x, you know that your cosine of x graph goes like this. So when you go to negative infinity on these, or positive infinity on this side, you see that you don't have value actually. It is oscillating between -1 and +1. So for cosine x function also, no horizontal asymptote. We are done. Now we'll see in our next part how we deal with limit when x approaches plus infinity or minus infinity. Basically, we are searching for horizontal asymptotes. All right, so we are coming to our next topic. It is about horizontal asymptotes and limit at infinity. In this case, especially, we are taking when x approaches to plus infinity or minus infinity. So first of all, the concept we have learned in pre-calculus can be applied here too. So when we are taking x approaches to plus infinity or minus infinity, we are basically looking for the horizontal asymptote for this kind of rational functions. So in this case, what I need, just the higher order term, which is known as power function. So you just take 3x in the numerator. In the denominator, your higher order term is 4x squared. The rest you can ignore. So at the end, you see that x will cancel out, another x will be in the denominator. So then it look like x goes to negative infinity. So you have 3 over 4x, and that goes to 0 because your denominator is very, very large. So the limit for this one is 0. In this case, we do the same thing. Limit x approaches infinity, higher order term is 3x, then we have 4x squared, and the same way it goes to 0. But example 3 and 4 is very important. Just pay attention. When I'm saying x approaches to infinity, you have a square root sign. So then you take the higher order term, just like example 1 and 2. So here we say square root of x squared over x. Now we understand that square root of x squared by definition is absolute value of x. When I know that my x approaches to infinity, I say that my x is greater than 0. So then this one simply you can say x is okay. So that means you are getting limit x approaches infinity, x over x. So your limit is 1. But look at example 4. Now x approaches to negative infinity. So in this case, I need to be very careful. X approaches negative infinity. I'm taking higher order term in the numerator denominator. Now again, if I use the definition of absolute value, so I need to say this is negative x because x is less than 0. My x is approaching negative infinity in the left side, so then it will be negative x. So in the top you are getting negative x, in the bottom you have just x. So this gives you negative 1. We now want to confirm this using our graphing calculator. Let us see this. So you can see in the calculator I'm taking first example 3. Now let us make window, we can say 0 is okay, because I want to check at infinity. So let me take it 500. Sometimes we take more than 500. And then graph it and trace it to that big number, close to that big number. Let me test at 499. So go to trace, put 499. And see that your limit is coming 0.9900, something like this, right? That we say close to 1. So this one, if you now put 1000 and put here 999, you will see that the number will be approaching to 1. So that is the idea. Now we want to check our second one when I have negative infinity. So I just need to change my window here. Let me put negative 500. And on this side, since I am not checking on right side, put a 0. Graph it and then trace at, say, negative 499. Trace negative 499. And you see that the answer is going close to negative 1. So that's the idea. And number 1 and 2 also you can check the same way, you will find it. So these are actually horizontal asymptotes.